Alright, chapter 7 is all about ionic and metallic bonding. So we're going to talk about all this kind of stuff. I could have made this chemistry pun, but I didn't want to. So we have our other picture for our chemistry pun. So this is a cave in Mexico. These are ionic crystals. It's a type of salt that grows in caves down in Mexico. And it's kind of hard to see, but there are people climbing inside this cavern. So you can kind of get an idea of how big these crystals actually are. So like this person is holding that person up, and that guy's right there. So you guys see how massive these are? This was only found like in the last 20 years. So this cavern has been untouched by humans for who knows how long, so that these things could grow so big. But they have to wear protective suits when they go underneath because the air quality is so toxic that it could like burn their skin, just like how when we use chemicals in chemistry lab and you have to be careful. The same kind of thing. It's just airborne, and so that might hurt them. And so they have to wear special suits, breathe special oxygen tanks, and they can only stand for a certain amount of time. But this is a real world example of an ionic compound. That's something different than just our normal table salt. Okay? So in this chapter, and the next couple chapters, we need to know what valence electrons are. A valence electron is an electron in the highest or outermost farthest away from the nucleus occupied energy of an element's atom. So in chapter 5, when we did our electron configurations, we were just starting with 1s, and we work all the way up to whatever. Well, now we are only going to use valence electrons. And so we're going to have set numbers based on the arrangement from the periodic table. So to find the number of valence electrons in an element, you just look at its group number, which would be at the top column of the periodic table. So if you don't have your periodic table, maybe grab that now. So when we filled in our periodic table, we made our columns. The alkali metals were column 1A, and that starts with hydrogen, that column. And then beryllium is the alkaline earth, that's 2A. So that A, the number with the A, tells you how many valence electrons are in every element in that column, in that group. Okay? So that is going to be easy as long as you know what that means. So noble gases have A valence electrons because their electron configuration is a full s and p orbital. Another way to know that, the noble gas column is column 8A. Okay? So the octet rule comes in because everybody wants to be like a noble gas. The octet rule states that in forming compounds, atoms tend to achieve the electron configuration of a noble gas. So, somebody throw out noble gas. What's one of the noble gases that's in there?
Argon.
Argon. Okay, thanks for not choosing xenon. So argon has how many valence electrons? Or how many electrons total, I should say. How many electrons total for argon? 18. So, and I'm just going to do this quick, but if we were doing our electron configuration from last chapter, either using the arrows or using their periodic table, it would be 1s2, 2s2, 2p6, 3s2, 3p6. That's 18, right? 2, 4, 10, 12, 18. Yes. Okay. So the way that from electron configuration you get the valence electrons comes from the orbitals. Okay? So the number in front, remember, is the energy level. And so we're talking about only the electrons in the highest energy level. So for argon, the highest energy level is 3. Okay? Because we have 3s and we have 3p. No 4. So that's why 3 is the highest. Then also, we count up all of the electrons in that highest energy level. And so we have 2 electrons in the s and 6 in the p. So that makes a total of 8 electrons. So that's where noble gases get that column AA has 8 valence electrons. Okay? You don't have to know how to do it this way. You just need to know noble gases have 8. But there is an exception. So helium is going to be the exception because the atomic number is 2, so the most electrons that helium could ever possibly contain is 2 electrons. So even though we say it's the octet rule, octet meaning 8, like an octopus has 8 legs, helium's going to have a completed octet when it has 2 electrons. Okay? just an exception. We're going to use these numbers, the column numbers, the valence electrons, to make what are called electron dot structures, okay? The electron dot structures are diagrams that show our valence electrons in dots. So, I have these pictures in your note packet, but, so, chlorine, we're going to write the symbol in the middle, and then chlorine is in column 7A, so we put 7 dots around. Calcium is in 2A, so we put 2 dots. Phosphorus is in 5A, so it gets 5 dots, okay? When you're filling in the dots, you have to make sure that you put 1 on each side of the 4 sides. Think about it being a box around it. So you put 1 dot in each box, or on each side of the box, and then once you get to 4, then you can start doubling it up, okay? So let's try. We're going to write this symbol in the center, find out how many valence electrons it has, and then fill in the dots around the symbol. Okay, so bromine, what's the symbol for bromine? Br. Okay, so you can go ahead and write Br. And what column, where's bromine located? It's a halogen, right? And so that's in 7A. So that means that we need to have 7 valence electrons or 7 dots around it. So when we start filling in the 7 dots, we are going to put, and it doesn't matter which side you start on, because if yours ends up looking a little bit different than mine, that's okay, as long as you have 7 dots. So I'm going to start at the top. So I'm going to go 1, 2, 3, 4. Now that I have 4, I can start doubling up. So then 5, 6, 7. So I have 3 sides with 2 dots each and 1 side with just 1 dot. If your side with the 1 dot would be like on top or on the left or the right, that is okay. As long as you have 7 dots, 2 per side and then 1 with 1 dot. That's fine. Okay? What about potassium? What's the symbol for potassium? K. And what column is potassium in? 1A, so that's going to have 1 valence electron. So you can pick your side and put your 1 dot wherever you want. I'm going to put mine over there. And that's how you do an electron dot structure. No, the most valence electrons you can have is 8. So once you have 2 on each side, then you can't have any more. So it won't ever triple up. If it's a noble gas, you can put 8 around it. Yeah. Okay, we're going to keep going just a little bit longer. Technical difficulties make this a little bit longer. We're going to talk about cations again today. A lot of people are calling it a cation, like a vacation, but it's a cation. Keep the 2 words separate, okay? Cation is a positively charged ion, vocab word from chapter 6, and it's produced when an atom loses 1 or more valence electrons to reduce to its octet, okay? So we have to remember that cations lose enough valence electrons so they have the same electrons as a noble gas, and it's usually that noble gas that's directly before it. Okay? And so an easy way to remember the number of electrons lost is by counting back on the periodic table until the noble gas is reached. Okay? So we're going to see this with our group 1A cations and our group 2A cations. And we're not necessarily going to be thinking about 8 electrons. We're just going to think about the total number of electrons for now. The anions that we're going to talk about tomorrow, it's easier to focus on the other one. So, group 1A cations. And every element in the alkali metal group is going to have a +1 charge because they only have to lose 1 electron in order to be like a noble gas. Okay? For example, Na stands for what? Sodium. How many total electrons does sodium have? What's the atomic number of sodium? 11. Okay. So, we are going to lose electrons from this total number until it's like a noble gas, because everybody wants to be like a noble gas. I'm going to say that a million times this chapter. So, looking at the noble gas column, what's the closest one that doesn't go over 11? Neon. And neon has how many? Okay, so we will write out an ion by saying that sodium has a +1 charge because this means that sodium loses one of its 11 electrons to now have 10 electrons. So it's like neon, okay? And yes, it does have a completed octet, but sometimes with cations it's easier just to see the whole. So with a cation, we can count and see, okay, I only need to lose one electron to be like neon and have 10 electrons. I'm good, okay? Let's try with the group 2A, the alkaline earth. Is it okay if I erase? Okay. Next, we have alkaline earth, which are 2A, and they have to lose 2 valence electrons. So we have Sr. What does Sr stand for? Strontium. And how many total electrons does strontium have? 38 total electrons. Okay. And it's in group 2A. What's the closest noble gas that doesn't go over? Krypton has how many? Has 36 total. So, if I lose 2 electrons from strontium, it's going to act like krypton. So, by having this Sr plus 2, that's telling that we lost 2 electrons to be like krypton. Okay? When we have charges, column 1A is always going to have a plus 1 charge. Column 2A, always going to have a plus 2 charge. What about 3A? Plus 3 charge. What about 4A? Plus 4 charge. Okay? I know, crazy. Alright, so last but not least, we need to name our ions. Okay, so when we have a cation, it's going to have a positive charge, and the charge is going to be whatever the column number is, that's going to be its positive charge. So plus 1, plus 2, plus 3, plus 4. Okay? That's talking about how many valence electrons it has and what it loses to act like the noble gas. So for the element lithium, how many valence electrons is that going to have? Look on the periodic table. What column is it in? Lithium is in column 1A. So if it has a 1, that means it has 1 valence electron. So I'm going to put 1 VE for valence electron. Okay? So that means when I write the ion symbol, I'm going to put lithium symbol, so Li. And then if it has 1 valence electron, that's how many valence electrons it has to lose to act like the noble gas. So I'm going to have a positive 1 charge. It's backwards thinking. If you're losing electrons, you become more positive because it's like subtracting a negative number. Okay? Then, the ion name is simply the name of the element and then as a separate word, ion after it. So lithium ion, separated ion. Keep a separation. Lithium ion would be the name of Li plus 1. Okay? So what about magnesium? That's in column 2A. So that has 2 valence electrons. So that means our symbol, ion symbol, is going to be Mg plus 2. And then the name of it will be magnesium ion. Separated word. Ion is a separate word. The next one will be called aluminum ion. Yes. And how many valence electrons does aluminum have to lose? What column is aluminum in? 3. So it has 3 valence electrons to lose, so that will be Al plus 3. And then last but not least, we have carbon. And carbon is in 4A. So it has 4 valence electrons. So that's going to be a plus 4 charge. And that name will be carbon ion. And that's it. That's all she wrote.